When a flash flood hits a rural village, the most dangerous phase is what emergency managers call minute zero. The immediate threat is the instant collapse of the physical world. Roads turn into impassable mud trenches, bridges wash out, and standard supply lines snap. Local first responders are effectively grounded. With no ground access and local cell networks failing, they have no way to locate where the need is most critical. Surviving those first critical hours requires an intervention model that completely bypasses the reliance on broken ground infrastructure. The Meghdev Drone Station by Ojas Aerospace serves as a fortified, self-sustaining aerial command center, strategically positioned on the outskirts of vulnerable districts. Built from 40-foot modular shipping containers, the station is ruggedized for the field. It runs entirely off-grid, powered by its own dedicated solar energy arrays. When storms knock out local cell towers, the station doesn't go dark. It automatically switches to a VSAT satellite backup system to keep its data link online. The container becomes a highly fortified digital island. When every other system fails, it retains the power and connectivity to coordinate the regional survival effort. Inside the command module, an emergency trigger shifts operators into a high-urgency workflow. Using a cloud-connected dashboard, they pull in exact coordinates of the disaster zone and generate an automated flight plan in seconds. Navigating India's strict aviation rules, the terminal uses NPNT, no permission, no takeoff, to request a digital flight token from the government server. This secure token is beamed straight to the drone. Only when the hardware validates the key will the rotors physically arm. While the software clears the airspace, human technicians in the adjoining repair bay run final physical checks on the massive multi-rotor frames. Because the software compliance and hardware prop happen simultaneously, operators can deploy a fully legal, life-saving flight within a strict 5-minute window. These are heavy-duty machines. They are specifically designed to punch through high winds and aggressive storm fronts. Equipped with infrared thermal imaging, they scan dense forests and flooded fields in zero-visibility night conditions to locate human heat signatures. For massive fires or industrial disasters, the drones establish an 8-kilometer communication range, beaming live, high-resolution video feeds straight back to government control rooms. They fly fast and low, navigating autonomously over terrain that would stop a convoy of rescue trucks in its tracks. Once they reach isolated survivors, they lower critical payloads, emergency medical kits, vaccines, and automated defibrillators directly into their hands. They function as a physical extension of the rescue teams, immediately closing the distance between stranded victims and the medical aid they need to survive. Guided by precise coordinates relayed from the air, ground teams can finally navigate straight to the stranded civilians and pull them to safety. Back at the command center, returning drones land on the container helipad. Technicians immediately hot-swap their depleted batteries at dedicated charging bays. Within minutes, the station resets to full readiness. It operates as a continuous loop of aerial intelligence and supply, actively managing the crisis until the floodwaters recede. Ojas Aerospace is scaling this modular container model into a national infrastructure. By strategically placing these drone stations at the district level across the country, they are assembling a massive redundant safety net. These large district hubs serve as the backbone, connecting downward to smaller block and village-level centers so even the most remote communities have coverage. When ground infrastructure breaks down, survival depends on the sky. Building a decentralized local drone network ensures that rapid aerial rescue is permanently stationed exactly where it's needed most.